Welcome everyone. So last class we discussed about L'Hopital's rule. So today I'll finish the remaining set of problems. So recall roughly what L'Hopital's rule is about. If you had limit as x goes to a, f of x over g of x, so you need a ratio here of two functions. And if it's of form 0 over 0 or infinity over infinity form, the sign doesn't matter, plus or minus. Then L'Hopital rule tells us that this is going to be limit as x goes to a of f prime x over g prime x. Okay, so this is what the L'Hopital's rule is about. So let's work on few problems, continuing from the last time. So let's look at problem 1 here. So limit as x goes to 0 of e to the power x minus 1 over sine 2x. Again, let's first check whether can we apply L'Hopital's rule or not. So let's see if it is of indeterminate form. So as x goes to 0, e to the 0 is 1, 1 minus 1 is 0, and sine 0 is 0. So we get 0 over 0 form. So by L'Hopital's rule, this limit is going to be limit as x goes to 0, derivative of top, numerator is e to the x minus 1, so derivative of minus 1 is 0, so that disappears, and derivative of bottom is sine, derivative is cosine, so cosine of 2x multiplied by 2. All right, and now as x goes to 0, let's see, what do we get? We get, on top we get 1, in the bottom we get 2, so indeed the answer is 1 over 2. So this is how you compute the limit using L'Hopital's rule. Okay, so let's work on the next problem. As x goes to infinity of e to the x over x squared plus x. Again, as x goes to infinity, e to the x also goes to infinity. So this is of infinity over infinity form. So by L'Hopital's rule, this is going to be limit as x goes to infinity, derivative of e to the x is e to the x, derivative of the denominator is 2x plus 1. Now, again, if you check this is of form infinity over infinity, so I can apply L'Hopital's rule again. I'll write L prime H for L'Hopital's rule, short form. So this is going to be limit as x goes to infinity, derivative of top is, again, e to the x derivative is e to the x, derivative of bottom is 2. And now as x goes to infinity, the top goes to infinity, the bottom is fixed to, so therefore the limit is infinity. So this is how L'Hopital's rule works. So you see that you applied L'Hopital's rule twice to get to the answer. Let's look at the next one now. So here again, as x goes to infinity, ln x goes to infinity, right? Recall ln x graph. This is how the ln x graph looks like, right? It'll keep on, this will go to infinity as x goes to infinity. And square root of x also goes to infinity as x goes to infinity. So this is of infinity over infinity form. So therefore, by L'Hopital's rule, this is going to be limit as x goes to infinity. Now, what is derivative of ln x is 1 over x. What is derivative of square root of x? 1 by 2 root x. Now, this can be simplified as x goes to infinity, 1 by x times 2 square root of x, which is going to be limit as x goes to infinity, 2 by square root of x. And as x goes to infinity, this will 1 over that power of that goes to 0. So this will become 0. All right. So let's move to the next one. So there are 7 indeterminate forms. So we already have talked about 0 or 0, infinity or infinity. Now the next one we're going to discuss is 0 times infinity. So first of all, let's check whether it's of that form. So as x goes to infinity, x goes to infinity, right? This goes to infinity. What about this guy? So let's check that out. Limit as x goes to infinity of x minus 1, x plus 1, which is same as limit as x goes to infinity of 1 upon 1 minus x, 1 plus 1 by x, dividing inside by x on numerator and denominator both. So this is going to be ln1, which is going to be 0. So clearly it's of form. So this is of form 0 times infinity, right? Sorry, okay, other way around, right? Infinity times 0, the same thing, right? Now we can apply L'Hopital's rule, but for L'Hopital's rule, we need a fraction. So let's say this limit as x goes to infinity. Now we'll keep one on the top and the other one in the bottom. Which one? That is totally up to you. So let's say we'll keep ln of x minus 1 divided by x plus 1 on the top, and bring this guy on the down as x squared. Now this is going to be limit as x goes to infinity. Note that derivative of this is minus 1 by x squared, the denominator. Now what is derivative of top? Now, I mean, I can either work it out here using quotient rule. So, sorry, using chain rule first. So chain rule will tell me that it will be derivative 1 over, derivative of ln x is 1 over x. And then I multiply with derivative of inside, or I can work it out here. So let me just work it out here. What is the derivative of ln of x minus 1 upon x plus 1? First of all, even before I take a derivative, I will use some property of ln. So this is d by dx of ln of x minus 1 minus ln of x plus 1. That bracket part is unnecessary. So let me just erase that. And now that derivative of ln of x minus 1 is 1 upon x minus 1, and the other one is 1 upon x plus 1, right? So now I can write that directly here. So I get 1 upon x minus 1, 1 upon x plus 1. All right, so now let's simplify it a bit. So this will amount to some cross multiplication and simplification as x goes to infinity. X plus 1 minus x minus 1 divided by x square minus 1, the whole divided by 1 minus x square. Now, before I go further, I'd like to simplify it a bit. So we get limit as x goes to infinity. X will cancel, 1 minus, so 2 upon x squared minus 1. And you're dividing by this guy. So it's same as multiplying by the reciprocal. So 1 by x squared. So this is going to be limit as x goes to infinity minus 2x squared upon x squared minus 1. Again, so this was L'Hopital's rule here. By L'Hopital's rule, this one we again have to check, and you can check that this is infinity over infinity form. Actually, it's minus infinity over infinity form. They are same thing. Now we can apply L'Hopital's rule again. So let me by limit as x goes to infinity, derivative of top is minus 4x, derivative of bottom is 2x. These can cancel off. The answer is minus 2. So this is another problem done. Now, let's move on to the next problem. So fourth kind of indeterminate form, infinity minus infinity. Why it is an indeterminate form? We have already discussed that in the last class. We also did this problem in the last class, but let's just finish this sequentially. So Clearly, as x goes to 0, I should make it plus. You'll argue, why is that? Well, we could have worked out without being plus on the top, but if it is x goes to 0, 1 by x does not really exist, right? Because the left-hand limit is, recall, if you go from the left hand, the limit is minus infinity. If you go from the right hand side, the limit is plus infinity. So this limit does not exist. Although I could have worked with x going to 0 by taking left hand and right hand and showing that they're equal, but let's just work with this. Okay, so limit of x goes to 0 plus of 1 by x minus 1 by sine x. So it's of infinity minus infinity form, as you can see. Now, to apply L'Hopital's rule, we need one function divided by another. So we'll cross multiply and simplify. So this limit is going to be limit as x goes to 0 plus sine x minus x over x sine x. Right. Now check whether we can apply L'Hopital's rule. So as x goes to 0 plus, sine 0 is 0, x 0, so 0 minus 0 is 0. The denominator is also going to 0. So it's of 0 over 0 form. So when you apply L'Hopital's rule, this is going to be limit as x goes to 0 plus, derivative of sine is cosine x minus 1. Derivative of bottom is x times derivative of sine x is cosine x plus sine x times derivative of x, which is 1. So I'm using product rule in the denominator. All right. Now let's check again. Do we need to apply L'Hopital's rule, or can we substitute and get your answer? So as x goes to 0 plus, so cos 0 is 1. So 1 minus 1 again 0. And as x goes to 0, this part becomes 0. This part also becomes 0. So again 0 over 0 form. So we'll apply L'Hopital's rule again. And we get what? Limit as x goes to 0 plus. Now derivative of cosine is minus sine. Now what do we get in the bottom? Let's see. So x times derivative of cosine, which is minus sine, plus cosine times derivative of x, which is so cosine x, plus derivative of derivative of sine x, which is also cosine x. So you got this now. Now let's check again. Do we need to apply L'Hopital's rule? So as x goes to 0 plus, the top becomes 0, the bottom becomes, this part becomes 0, but cos 0 is 1. So this is 1, this is 1. So you're left with minus 0 by 2, which is 0. So this is your limit for this function. Okay. So let's move on to the next part. So these are the three more indeterminate forms. So in total we have 7, as we said. So 0 over 0, infinity over infinity, 0 times infinity, and infinity minus infinity. All right. Okay. So in these situations, you have to apply L'Hopital's rule. All right. Or in this situation, the limits cannot be determined just by substituting. Okay. So let's move on to the next part. As x goes to 0, we have cos 0 becomes 1, and x goes to 0, 1 by x square goes to, so x square goes to 0, so 1 by x square goes to infinity, right? Because it has a positive sign. So this is a form 1, because cos 0 is 1 to the power infinity. So as you can see, this form here. So we'll need to apply L'Hopital's rule. But note that for L'Hopital's rule, we need fx divided by gx, right? We need one function divided by another. So we do not have that here. So what we'll do is we'll try to get to that. So let's say to bring that power down, we have to use ln on both sides. So let ln, let this be L, this limit be L. So ln L is equal to, so ln L is going to be ln of this limit 1 by x square, and the ln can jump in. So x square, and the power, the prop using property of log, this will be ln of cos x over x square. Now note that I used here something. I'm already assuming that the limit exists and I'm finding it, okay? So now we have this limit which we need to compute. So instead of finding the limit L, we are finding ln L. But that's all right. So now let's check. As x goes to 0, cos 0 goes to 1. So ln of 1 is 0. So it's of 0 on the bottom, sorry, 0 on the top. And as x goes to 0, x square also goes to 0. So 0 over 0 form. So this, by L'Hospital's rule, is going to be limit as x goes to 0, derivative of ln of cos x is 1 by cos x times derivative of cos x, which is minus sin x, divided by, now what is derivative of x square? 2x. Now if I do a little bit of rearrangement, this is limit as x goes to 0 minus tan x over 2x. Now this is again of form 0 over 0, right? Because tan 0 is 0. And when you put 0 in the bottom, you get 0. So 0 0 form. So I can again apply L'Hospital's rule. So by L'Hospital's rule, this is going to be limit as x goes to 0. Now derivative of tan is secant square. So this is going to be minus secant square x. Derivative of 2x is going to be 2. And as x goes to 0, secant 0 is 1 over cos 0, which is 1. Oops. So, so therefore this is going to be minus 1 over 2. Hold on. So this is your ln L. So ln L is 1 over 2. So this implies L is e to the power 1 by 2. So this takes care of your discussion about L'Hospital's rule. And tomorrow we'll discuss about optimization problem. Good luck. Stay safe.